Adjunct Professor Moran, Microeconomics 112. In this chapter, we're going to be discussing pure competition. From our last video, you discovered that the way businesses compete for your demand for their product is through one of four types of business competition: pure competition, monopolistic competition, oligopoly, and monopoly, listed from the best for society to the worst for society. Here we're going to focus on pure competition. The assumptions for pure competition are characteristics of a purely competitive market are many sellers acting independently. Each seller is selling an identical product. Products are viewed as perfect substitutes, and so consumers will make their decisions based on price alone. We're going to assume that sellers are price takers. They have to sell at the market price. If they try to sell at a higher price, people will substitute to the identical product sold by their competitors. And there would be no reason to sell below market price, because in this model we're assuming that each competitor is such an infinitesimally small part of the overall whole that he can sell as much as he wants at the equilibrium price. Now, why would he, if he's assumed able to sell an unlimited amount at the market price, why wouldn't he sell an unlimited amount? And the point is that he is not trying to sell as much as possible, a perfect competitor. He's trying to profit maximize, which will not happen past a certain amount of quantity. Let's take this opportunity to point out that what we're trying to do in this unit is determine the price and quantity that each type of competitor will produce, because as economists we want to see the lowest prices and the greatest quantity produced in order to overcome scarcity. And pure competition will do a better job of this by providing lower prices and greater quantities than any of the other types of business competition. The individual firm's demand curve is perfectly elastic. The market won't be, but the firms will be. And what do we mean by that? We'll eventually graph this with numbers and you'll see it all. But right now what we're talking about is we're going to have a firm's graph and an industry's graph. And the demand for the product from the market has a negative slope. But the individual competitor has a perfectly elastic demand curve. So theoretically they can sell as much as they want at that current price. But they'll be taking this price from the market. And that's where the price will come from for the individual firm. We're going to assume that there are no barriers to entry, that if there is an economic profit being made, that firms will be free to enter this industry, and when more firms enter the industry, the supply will increase, the supply curve will shift to the right, resulting in a lower price and a greater quantity, eliminating the economic profit. And if there's an economic loss, then there are no barriers to entry, and firms can leave the industry, shifting supply to the left, causing a reduced quantity and a higher price, eliminating the economic loss. Pure competition is a fairy tale. It's like an ideal. It's something you want to achieve, but these assumptions are completely unrealistic. You can't have all four of these assumptions at any one time. Some industries have some of the assumptions, some have others, but it's very difficult to find an industry with all of these assumptions. Farming, for example, there are barriers to entry. The cost of the land and the equipment is very high. It's true that the products are identical. A grade A tomato is the same as another grade A tomato. Fishing boats are expensive. Financial markets, you need you need a stock exchange, and it's very hard to get a seat on an exchange. Basic metals, mines are expensive to operate. So these have some of the characteristics of purely competitive markets, but in fact aren't. The reason we want to know about pure competition if it can't be attained in real life is because it's the ideal, and we want to know how far away from the ideal we're getting with the other forms of competition. And when conditions stray too far, perhaps the government should interfere in order to promote more competition. and a better price quantity outcome for society. Now, there are two approaches to price quantity determination. There is a total revenue and total cost approach. Then there is a marginal revenue and marginal cost approach. We'll begin by discussing the total revenue, total cost approach, but it's really the marginal revenue and marginal cost approach that we want to use to compare the four types of business output and pricing. And that's because when you do a marginal revenue and marginal cost approach, you're also going to be using averages as part of that approach. An average cost can be directly compared to the product price because both an average cost and a price are on a per unit basis of sale. Whereas if you use a total cost and total revenue approach, you're dealing with large numbers that when you can't directly compare to price. So this is the decision rule we eventually want to get to, and we want to set marginal cost equal to marginal revenue, demand, and price. Marginal revenue, demand, and price, as we're going to demonstrate shortly, will all be equal, but only for a purely competitive firm. We're going to set all of that equal to marginal cost. If we do that, the firm will achieve its best outcome, and there are only three outcomes that can be achieved by the firm. A firm can either profit maximize, shut down, or in between loss minimize. Let's take a look at this rule and see what that's about. So this is a preview of what we're really going to try to achieve towards the end of this chapter, although we're going to be taking a detour to talk about the total revenue and total cost approach, which you can't use this in. So we've got, we're going to set marginal revenue, which equals demand, which equals price. We're going to set all of that equal to marginal cost. And if we do that, if we find that point, then what's going to happen is we're either going to profit maximize, loss minimize, or shut down. Okay. If price is greater than total cost, and total cost is greater than, hold on a minute, I'm wandering into the reservation here. Right. Average total cost. And average total cost is always greater than average variable cost. If price is greater than average total cost, then the firm is profit maximizing. It's making a profit on each unit it sells. But if a firm finds itself in the position where average total cost is greater than price, and price is greater than average variable cost, the firm will be losing money. But it doesn't necessarily mean that in the short run it should shut down. That's because if the price is larger than its average variable cost, letting one worker in the building, if you could charge 11 and only pay the worker 10, then you've made $1 on your variable cost, which you can use to pay down your fixed cost, whether you're open or not. You have to pay your average fixed cost, which is part of your average total cost. So by making a profit in the short run on your variable cost, it allows you to loss minimize, because the loss for this firm will be reduced. Their loss would be larger if they close down, because they'll have to pay their fixed cost anyway. But by making a profit on their variable cost, their loss will be less than their fixed cost, and that's loss minimization. But when price falls lower than average variable cost, which is always lower than average total cost, then the firm is losing money on its variable inputs too. So you wouldn't let a worker in the building and pay him 11 if you're only selling the product for 10, because then you'd be incurring a loss on your variable cost as well as a loss on your fixed cost. And so your loss would be larger than if you shut down and only incurred a loss on your fixed cost. So these are the three outcomes that we're going to explore in order to determine price quantity reduction of a purely competitive firm. You're going to see that marginal revenue equals demand equals price for a purely competitive firm, because a purely competitive firm has a perfectly elastic demand curve. there it is. So price is constant and the demand curve is constant. Demand is a numeric table that expresses a relationship between price and quantity demanded. And so there's your demand curve, a perfectly elastic relationship, a relationship nonetheless. The market, the perfectly elastic relationship, but a relationship nonetheless. Whereas for the market, there will be this negative sloped one. Okay. Now, let's explore the total revenue approach. A firm's demand schedule equals its revenue schedule. What price is to a buyer is demand, is revenue to the seller. So total revenue equals price, column 1, times column 2. Price times quantity. This is not profit. This is how much the firm makes by selling its goods. You have to subtract cost from total revenue in order to calculate profit. Okay, so if the price in this market is 131, there's no output sold. 131 times 0 is 0. If there's 1 unit sold at 131, total revenue is 131. 2 units sold at 131 is 262. At 3 units sold at 131, price is 393. Now notice for the purely competitive firm, that marginal revenue, the extra revenue achieved from selling one more output, is equal to price. 131 minus 0 is 131. This is how you calculate marginal revenue. 262 minus 131 is 131. 393 minus 262 is 131. So hopefully you're beginning to see this identity, that marginal revenue equals price equals demand. The demand schedule here is right there. A numeric table that expresses a relationship between price and quantity. This is the demand schedule. This is the price, and this is marginal revenue. So we've just demonstrated our triple equality of marginal revenue equals demand equals price. And eventually we're going to set all of this, which is 131 in this example, equal to marginal cost, and that will result in the best outcome, whichever it is. So the firm will just have to accept the prevailing price and decide whether it's profit maximizing, should continue to stay down even though it's achieving a loss, or shut down. Now if we graph this, total revenue is a straight line from 0, from the origin, and the slope of this line equals the price. Every time quantity goes up by 1, this goes up by 131 in this example, the price. The price is constantly 131. They can sell an unlimited amount at the current market price. Okay, in our next video, we're going to add marginal cost, and we're going to analyze where this firm is going to go from break even, where they don't have a profit or a loss, profit maximize, and then we're going to graph that to demonstrate those points, profit maximization and break even.